Hello everyone, I am Aadarsh Pathak and I am a second year MSc student at IIT Indore. This video is basically dedicated to the poster which I am going to present in Astronomical Society of India 2021 meeting. So this is the title of my poster which I am going to present. So basically what's the idea is, I am using largest cluster statistics on simulated H121 centimeter map obtained from different reionization scenarios, and on the basis of which we are basically constraining reionization models. So these are the 7 reionization scenarios I was talking about. These 7 reionization scenarios are different from each other in a way they are using the source models. For example, if I'm talking about the scenarios like fiducial, clumping, and PLN is equal to 2 and 3, they are using the source models which are emitting ultraviolet photons emitting from the galaxies residing in dark matter halos. Similarly, these scenarios are basically emitting hard X-ray and soft X-ray photons respectively. So if you want to know more about these reionization scenarios, you can either contact me or you can go through the literature Mazumdar et al. 2016. Now these are the 3 steps which I am basically using in my work. So I am using the simulated H121 centimeter map of reionization scenarios, and I am applying the SUFGEN 2 algorithm on them, and by using the shape finding technique we are basically calculating the value of LCS. And once we are done with that, we analyze the LCS evolution, and on the basis of which we conclude interesting results. So here are the results which we have got so far. The first result shows the variation of largest cluster statistics with the neutral fraction. Largest cluster statistics is the fraction of the volume of largest ionized region with the volume of all ionized regions taken inside the simulation box. So we can see from the figure that the evolution of LCS is significantly different for all the 7 reionization scenarios, and even they are percolating at different neutral fractions as well. Thus, we can say that this LCS is robust enough to distinguish between the different reionization scenarios. We can also divide these 7 reionization scenarios in 2 broad categories. First one is the inside-out reionization, where we can consider scenarios like fiducial, clumping, PLN is equal to 2, 3. And another categorization is the outside-in reionization, where we can divide the scenarios like UIB dominated and SXR dominated in one regime. So these are the results which we have obtained from LCS versus Chi H1. Now this is the another interesting result which we have obtained. Here we have plotted the number of isolated clusters in log scale with the neutral fraction. We can see that the number of isolated clusters basically increases for all models, and after percolation they basically decrease in size. And if we are talking about the scenarios which are following outside in reionization, they are having the largest number of isolated cluster as compared to the scenarios which are following inside out. This result also gives two important conclusions. First, that the scenario following outside in reionization, they are having very low filling factor even at the end of reionization as compared to the inside out, where the filling factor's value is very large at the end. And the second is that the contribution of filling factor becomes significant in outside in reionization after a certain point or a neutral fraction, which is basically the percolation in our case, before which it almost remains constant. But this is not the case with the inside out reionization, where we can see that we have a considerable effect of filling factor in entire neutral fraction range. These two results basically show the topological evolution or the topological result obtained from the shape finders. We have plotted here the cross section and length with the neutral fraction and volume respectively, where length is in log scale and cross section is in linear scale. We can see that the length of LCS varies significantly as compared to the cross section, and thus we can infer that there is a one-to-one correspondence of length with the volume as well. And hence we can say that this kind of behavior is basically noticeable in filamentary topology, and thus the largest ionized region mainly follows filamentary behavior basically after percolation. And this result is not only limited to the fiducial, but the same kind of behavior has been observed for other ionization scenarios as well. So finally, what we can conclude, we can say that the LCS is enough to describe the topological behavior, and even we can differentiate between the different reionization scenarios. Further, as a part of this project, we are interested to find the cosmic variance related to the models, and we are also interested to find the bubble size distribution so that we can relate this LCS with them. This is all from my poster presentation. Thanks for listening.